First of all, we need to know some disadvantages of the traditional network. The first is called purely distributed. Pure distribution is, for example, I now have some equipment. I want to realize that two terminals can be interconnected. Then I need to run OSPF on these devices. Announce each other after running. To configure the interface address. Modify the device name. Then run OSPF. The announcement is to synchronize the routing table between devices. In order to allow this network segment and this network segment to be learned by all devices. Then let them both communicate. We just demonstrated a configuration like this today. So you will find, when facing networking in the future, only a few devices are fine. If there are many devices, you have to configure accordingly every time. Independent configuration for each device. Especially for projects. Of course, we now also have Gambit for Python automation. So this thing is not so absolute. But it is still somewhat different from the technology in SDN. Let's talk about automated opening. In fact, it is just some automatic configuration for the device. SDN is more advanced than that. Let's not talk about anything else. What about standalone configurations? This is a disadvantage now. Secondly, from the control level, each device is required to calculate independently. Actually, the device has two actions. The first is called data forwarding. The second is called calculation of data. Devices run OSPF on each other. Synchronize routes with each other. Its action on the routing table is called calculation. A router has many interfaces. A data comes in from an interface. The device queries the routing table for data forwarding. This process is called forwarding. So actually, forwarding and computing are two actions. But it's all done by the router. It is called each device to calculate independently. So, although the router performs data forwarding, but it needs to maintain its own routing table. You have to exchange messages every day. Take care of the neighbors. If not, the device has to recalculate. Plan the route. Switch some ready lines, etc. These are calculations. For example, there are now multiple paths to the same destination. Specifically, go up, step down, still going. This also needs to be calculated. So it's all called computing. After the calculation is completed, the table can be forwarded. Let's go on. Outdated software features without innovation. Multi-brand incompatible. Actually it means, you can summarize EIGRP in one sentence. For Cisco, this thing is much easier to talk about. You will find that EIGRP has almost no scenarios to use now. Except for some relatively small-scale commercial banks of a local nature. They are not regulated by the government. And is joint stock. Relatively rich. Cisco equipment can use EIGRP. Because neighbors converge quickly. Doesn't need to be as slow as OSPF. Indeed there are such. But rarely. Like some proprietary technologies in other manufacturers. Such as hybrid. It's like a policy based on VLAN. The traditional VLAN is. The same VLAN can communicate. Different VLANs cannot communicate. Different VLANs have to cross 3 layers to communicate. Not on the second floor. Hybrid can do it. Layer 2 communication between different VLANs can also be completed. It is equivalent to a strategy. But hybrid will only be used in Huawei. For example, voice VLAN. Few other scenes. These techniques are good. Because it is a proprietary technology. There is no way to ensure that all equipment from various manufacturers is combined in large projects. so no one uses. For example, others can use EIGRP, but we can only use OSPF. Then we don't use this EIGRP. I will not go to buy equipment that can use EIGRP. Its Cisco equipment is more expensive. We are all economical networking. Subject to the current conditions. The cheaper the better. Then the cheaper. We require equipment to use more public technology. Then it reverses and makes manufacturers unwilling to research new private technologies. Manufacturers have spent a lot of research and development funds for decades. Launched a technology such as EIGRP. The development cycle is quite long. After it was launched, no one used it. The money is wasted, including software feature incompatibility. In fact, it's all one meaning. It's because of brand incompatibility. We have been using public technology over time. Now there is no manufacturer to do private technology. Everyone likes to study hardware. Everybody knows. Proprietary technology has only two outcomes. The first is to be stolen. The second is useless. So it's not worth it. Manufacturers are also profit-seeking. Must put the economy first. Now we won't be developing proprietary technology anymore. You will find many factors combined. As a result, the advancement of traditional networks is very slow. Because there is no new technology. So SDN appeared. It is specially designed to solve the problems we just mentioned. SDN first makes a point. Forwarding control separation. Control is really computing. It is the calculation I just told you. It actually means forwarding control separation is make a distinction between forwarding and control. Retweet is retweet. Calculation is calculation. As a router, in the future, it does not need to calculate the routing table by itself to complete data forwarding. It is only responsible for forwarding. We introduce a device across the network. Controller hardware called SDN. It is responsible for calculating. After it completes the calculation, it sends the table directly to the device. This table is more than just a routing table. For example, you will learn the label in the future. It can also calculate. After it's over, directly forward the generated table to the device. The device gets this table and forwards it directly. As a router, it does not need to support OSPF anymore. Because it supports OSPF in order to establish neighbor synchronization routing table. Now the table has been directly made to it by the SDN controller hardware. It does not need to support OSPF anymore. It is equivalent to the separation of forwarding and control. Everything a router needs to forward. After the SDN controller hardware is calculated. Give it. Then the data is sent. It directly performs lookup table forwarding. No more calculations. This way for downstream equipment. They become a transponder. That is, into a transponder called a white box device. All control is done by devices such as the upper layer SDN. These downstream devices only need to perform table lookup and forwarding. Centralized control from one device. All downstream devices only need to complete the forwarding. Finally, the separation of forwarding and control can be realized. Let's simply draw a picture. Assuming this is the controller hardware for SDN. These are routers one by one. The original router had to run the protocol. You have to configure the address yourself. Don't bother. Now these devices. As long as SDN is supported. It is the SDN controller. The device can automatically find the SDN controller when it is turned on. Then it sends the configuration template to the device. The device does not need to be configured by itself. Do some corresponding configuration on the SDN controller. It can send down the appearance. Whether it is some basic configuration of the device, or a semblance of the future of computing, forwarded directly. The equipment below does not need to do anything. The advantage of this is maximize the reduction of some calculations of downstream equipment. Save hardware resources. The downstream device does not need to open the routing protocol anymore. The cost of equipment is reduced, because there is no need to buy high-end equipment. Okay. Let's talk about centralized control. One controller hardware can be centrally controlled. It can not only control the router, as long as the device supports SDN. Whether it is a switch, or router, or firewall, everything is possible. Wireless AP can support, as long as the device supports SDN, can be controlled by the SDN controller accordingly. The last one is called open interface. Now say that everyone may not fully understand. Let me talk about the meaning of open interface. It's like a platform. The platform is like an app store on your mobile phone now. What service do you need to go in and download? For example, in college, I am a network engineering major. Many of my classmates are engaged in game development. They develop their own games, and then upload it to the App Store. Play for free. It's a graduation project. So this kind of thing is equivalent to a platform. You can upload your own work. Certainly. It can also be paid. If anyone wants to play,